need energy. Now here's the deal about this needing energy thing. I'm not going to lie to you. I like to expend as little of it as possible. It is true for all scientists. So from here on out, when I say the word energy, I'm just going to write a capital letter E because all scientists understand capital E to mean energy. So all living things are going to need energy.
Don't light bulbs need energy going on?
Right, but are they going to have all the other characteristics of light? So we should probably think of more, right?
Yeah.
Needing that energy, how do we use that energy as living things? So we move, we grow, we think.
Just to do normal body functions.
Normal body functions. Is there a name for normal body functions? Now don't think about just animal-sized things. Think about, I don't know, bacteria-sized things. What could we call their normal body functions? There's a word we're going to hold on to. Keep that one.
Eat an extreme.
We could figure out what it is, like what that process is called. I take in food and I digest it. In an animal-sized thing, it's the digestive system. In something much smaller, we have the same word. Metabolism. Metabolism is how we extract energy from the stuff we intake from the environment. We metabolize by first digesting. Bacteria are going to metabolize as well. They have internal metabolism. They do the same thing. So do fungi, plants, everything that's alive. Now, Alan, I asked you to hold on to a word. What word was that? How many of you have heard that word before? So if I were to ask you, who do I think if I said, I dare you, would take me up in that dare? Oh, how did I end up looking at you? Figure. What would happen if I said, I dare you to eat 3 tablespoons of salt? Pure salt.
Do it.
Oh no, I know you'd do it. I mean, what would your body do?
It would upchuck.
Vomitosaurus rex, right? Like, yeah? So, couple choices. Either you're going to everywhere. Bye, football team. What's up when you talk about you while you're not here?
I can hear it later. It's recorded.
Small amounts. Small amounts you need. Large amounts, like tablespoons. What are we doing with that? What are we doing about the kid I pick on? I don't know how to operate in the classroom without like the one kid I can guarantee to pick on.
Choose Colin.
Who else here is like thick-skinned enough to be able to handle it?
Colin.
Liam.
Colin or Liam? Okay. Are you going to do Vomitosaurus rex? Because, he can't anymore. Okay. If you weren't going to vomit, is there something else that would happen?
I wouldn't feel good.
You wouldn't feel good? get dehydrated. You would get super thirsty, right? So your body is going to respond by ingesting a large amount of something that it's not supposed to have, by either upchucking it, like, hey, gotta get this out, gotta get it out now, I mean like right now, or you're gonna be like, I'm so thirsty. Fingers swell up like sausages, right? It's dreadful. I could pick on the football players because they're not in the football. Oh, delightful. Has anyone else noticed that locker room hallway
Smells.
is rank after school? That hallway makes me pray every time I walk by that if this is a boy, that it chooses swimming. Why? What's wrong with those Febreze needing people? Why are they sweating?
Because they're working hard.
They're working hard and it's what outside?
Really hard.
It's hot out. What is your body trying to do when it sweats? It's trying to cool itself off, right? Only if they played in cold seasons would the locker room not smell like that. I don't even know what to call it. Like, it's ode to football. No other sport I know. Even like ode to hockey bag is not that bad. And trust me, ode to hockey bag is nasty. None of it. It is the body's process of breaking down food for energy. Well, an organism's process of breaking down. I shouldn't say body because you guys think you associate body with like corpus. It's not always corpus. On these things. Bacteria don't really have a corpus, right? So we understand the idea that if we alter the environment of an organism, it's going to try and return back to normal. It's going to vomit, it's going to be thirsty, it's going to sweat, it's going to shiver. Those things are how an organism maintains homeostasis, how it maintains a normal, stable environment. All living things do it. They do it in different ways, and we're grateful for that because everything will smell like football if they do. But maintenance of a normal internal environment. ENV', by the way, is biologist abbreviation for environment. Isn't that like a big old long word? We're lazy. We haven't figured that out yet. Big short words. Well, thank goodness they left when they did, so we could pick up. Oh, it's starting. Good. Need energy, they metabolize, maintain homeostasis. What else do we know about living things? They grow. We agree living things must grow in some way, shape, or form. What that looks like depends on what the living thing is. If it's bacteria, it's going to grow to one cell from one, it's just divide in half really. Ooh, dividing in half. That's a form of what? Living things that fail to develop a method of reproduction do not a species make. They're going to die out, right? They go extinct. Else living things do. As what? How many of you are like, yes, all living things must be made of cells? I've heard this somewhere. That's good. That's a short change, sometimes lasting only a brief period of time, like a teeny tiny period of time, that response to stimuli, as long as the stimuli lasts That's as long as the response lasts. So I poke Colin with a sharp pointy stick. He only says ow for as long as I poke him. Agreed? Don't worry, I don't have any sharp pointy sticks.
Unless it impales. Not even start bleeding.
That's pretty rough.
Even after.
Yeah, then I'd have to like administer first aid, so I'll make sure it's not that hard. So, not out of concern for you, clearly it's so I don't have to administer first aid. Evolution, on the other hand, I want you to think about over the course of many, many, many generations. This is not a change in lifetime. You do not evolve over the course of your life. Not the same thing. Evolution occurs over many generations. Now here's the thing. If you are bacteria, generation time for bacteria is like 4 hours. So that's pretty snappy. It's generation time for a people.
Like 30 years. It's not much. Like 20 to 40 years.
Generation time for people is probably 40-ish years. Right? Slightly less. It depends what country you're in. Why would generation time depend what country you're in?
Is that why viruses can just change real quickly and there's new vaccines like every year as it evolves?
That is precisely what makes vaccines, or what makes the flu virus, for example, change
Because
so
they're,
very
like,
quickly.
Short, like, they can just keep changing.
All the other questions, because if we live in a third world country, we don't have as much like medical stuff or food as we do.
Access to medical care and typically younger birth rates, right? Like United States, we have most women delay starting families until late 20s, early 30s in the United States. Other countries, it's different. So different generation time for humans, which is why we have to go like average generation time. If it was like the way it used to be old school, it was as soon as you were able to reproduce, so it would have been like 20-ish years. So generation time depends on what the living thing is. So evolution can be snappy for tiny things with fast generation times. But things like, the Galapagos tortoise that lives 200 years, it takes a while for it to reach a generation time. That's slow. So evolution is change over large amounts of time. And I don't expect us yet to know the mechanism for it, but all living things are capable of doing so. I won't get into semantics yet. Capable of doing so. Are you able to take those characteristics of life and apply them then to the things with which you are unfamiliar? Which one of them is going to be difficult to observe in a petri dish? Which one? Evolution's going to be pretty rough, right? Like, I don't precisely know how you could do that. Oh, well, with this one you could. That one totally possible. The others, not so much. The one that I don't know that necessarily we would get to on our own in discussion is this one. Ah, I have to know all of the other sciences to be able to do this. Thought we got to ignore the ones no one likes, like physics. Poor Mr. Nanini. He never hears the end of it from me.
I was going to say this one, but I thought that just went in with metabolism.
This one means anything, including living systems, like ecosystems, biospheres, the biome, they all also have to observe laws of chemistry and physics, or rules of chemistry and physics. Some of you are like, but I don't know the rules of physics. Yes, you do. I bet you know a lot of them already. If I were to say the first and second laws of thermodynamics, you'd be like, yeah, don't know. But if I were to say energy cannot be created nor destroyed, or can be neither created nor destroyed, you'd be like, yeah, sure, that's a rule. Everybody knows that, right? You can't make energy. You can't create it. You can convert it from one form to another, but I'm not just gonna like mad wizard make energy. So all living things have to observe that one. It's a rule of physics. Same thing for rules of chemistry. Matter cannot be created nor destroyed, so like this spontaneous generation thing. You guys familiar with the theory of spontaneous generation? Back in the day, they used to believe that living things could come from nowhere. So, for example, if you were to leave meat out on the counter, this is a famous science experiment. If you were to leave meat out on the counter, maggots would appear on it, right? If you left it out there for an extended amount of time. They used to believe the maggots just appeared out of nowhere, like spontaneously, just like, hey, rotting meat makes maggots. It took them a little while to figure out that actually flies came and laid eggs, and then the eggs developed into maggots, and then the maggots developed into flies. They were a little behind on that one. But they figured it out eventually. Took Reddy's experiments to figure it out, but we'll forgive them for being slow. Every single living thing has to operate within the confines of the physical world. So all living things, in biology we studied, these are the things we're constrained by.
Doesn't every non-living thing also have to obey by these rules?
Mm-hmm.
Okay.
I know, you're like, why is it a characteristic of life? I don't know.
Okay.
Anything in the physical world has to obey these rules. Except this one's always like flummoxed me, right? See if I can flummox you as well. Your soul is a thing, right? Like you've got it. Where is it?
Somewhere.
Right? Like,
It's like Peter Pan, it's just not
should I, like, do I make sure that I don't get, like, kicked in the shin? Do I make sure, like residing somewhere beneath my lung, but it's, like, clearly with my body if it leaves my body? This has always bothered me. This is serious. And I have inquired with multiple people who would know. Parish priests, by the way, don't particularly appreciate that question, so don't ask. It's kind of like that whole angels being boys, girls thing. Another interesting conversation.
My mom used to tell me, because I asked her that question all the time, and she said your soul is like your shadow. It follows you because it follows whenever you bring your reflection on it.
See what? But then what? Well, where is it?
It's right there, I find it behind the shadow.
It's right there.
Mine's blown. We're all confused. I'm just saying, people are always telling me to look out for it, right? They're always like, "Oh, protect it, make good choices, don't corrupt it," and then I'm like, so if all of these things are true, the only way to make sure we can apply those things to these things is through a specific process. Science, biology, it's all a process, right? What science is not, and it totally bums me out that most people kind of assume that science is this. Science is not me just telling you facts and you memorizing them. Real science is you figuring them out. How do we figure them out? What does it mean to be real science or scientific? How about that? With your partner, discuss what it means to be scientific.